स्टार्ट झालं सर.
हो 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 स्टार्ट झालेला आहे ना.
हो हो लाईव्ह आहे आपण.
बरोबर.
ओके सर.
हा आवाज वगैरे येत आहे ना माझा.
हो सर हो येत आहे.
ओके ओके ठीक आहे मी स्टार्ट करतो मग शेअर
ओके
करतो
सर.
स्क्रीन शेअर होते की नाही एकदा बघून घेशील. ठीक आहे.
हो
हा दिसत आहे माझी स्क्रीन वगैरे दिसत आहे. हॅलो 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 प्रणय. हॅलो
सर दिसून राहिली आहे तुमची स्क्रीन.
आवाज आवाज वगैरे येतो का. हा स्क्रीन शेअरिंग दिसत आहे ना.
हो येतोय
ठीक आहे.
सर.
ओके ओके ठीक आहे ठीक आहे चलो थँक्यू व्हेरी मच.
ओके.
Thanks a lot, Pranay. So, dear friends, today we are going to see the GATE prerana module regarding the basically the operation research. So, the introduction to the operation research. This module we are going to see today. Okay. So, I hope that my slides are also visible to you. Okay, so let me check again. Yes. Okay. So today we will talk about the basically the operation research. Okay, and the topics which I am going to cover today, that is the introduction of the operation research, then the simplex method, and then the transportation model and the assignment model. So it will be around 2 hours lecture will be there, which will be focused on the particularly the operation research part of it. So the due to the advancement in the modern technological scientific technique, there is a growth of the operation research and there is a growth of the scientific techniques. So operation research is basically the recent addition to the scientific tool. You know that we use the scientific tool, we use the statistical tool, okay, to predict something or to find out the demand, and in case of the forecasting also we use the such kind of model or the scientific tool. So the operation research is one of the recent addition to the scientific tool. The OR it outlook to many conventional management problem, because in an industry the decision was taken based on the basically the experience and the skill of the person. For example, okay, how many products are to be manufactured, what will be the forecasting. This was all depending upon the person's experience and the skill, and the engineers or the managers or the decision maker, they used to make a decision based on their own skills. So in the conventional management problem, this was happening, which was basically replaced by the operation research. And in case of the operation research now, we use the database which is available with us and try to predict and apply the scientific technique, so that we can develop and we can take the better decision. So therefore, OR also it provides us the various alternative. Okay, that if this is not happening, then what we should do, like that. So the various types of alternatives are also being provided by the OR. It seeks the determination of the best optimum course of action of a decision problem under the limiting factor of limited resources. Okay. Then the development of the OR, the operation research, it has basically started from the military operation, which was used in the World War II, and which was pioneered by the British scientists. And the US military management was motivated by the development of new flight pattern, that is planning, sea mining, okay, then effective utilization of electronic equipment. So in the basically in the World War II, its use has been started. Operation Research. For example, the enemy is at a distance of 2 kilometers. Then how much explosive should be used to target the complete enemy? Okay, when the World War II was there, or otherwise, which equipment or what kind of range should be decided, so that the missiles or the rocket launchers, they basically falls onto the proper attack place, or it attacks the enemy and it harms the enemy. So during the World War II, the development of the OR or the use of the OR, Operation Research, it has been started. And after that, nowadays, it is used in the almost all kinds of industry. Okay, and it is one of the famous tool which is available for us, scientific tool for doing the analysis and taking the having the better decision. So the US, that is effective utilization of the electronic equipment. Then the similar operations were started in Canada and France. Until 50s, the use of OR confined to the military purposes. But after 50, the use of OR, operation research, it has been started effectively in case of the industry. And nowadays, many of the industries, they are using the operation research into their industry for taking up the decision. So OR in the industry, after World War II, the success attracted industrial managers to solve complex managerial problem. So in 1950, OR began to develop in industrial field in US. Okay, in 1953, Operation Research Society of America was formed, and in 1957, International Federation of Operation Research Society was there. So OR Society has also been started, and OR Society is looking for the development of the various tools, scientific tools, which is required for the industry. And a lot of research is being taking place in last 2 to 3 decades in the operation research, and many more new techniques, scientific technique, which is being developed, which is used by the industry personnel. So the question arises in our mind that what is the operation research? So basically, operation research can be considered as being the application of scientific method by interdisciplinary team to solve the problem, okay, so as to provide the solutions which best serve the purpose of the organization as a whole. Okay, Atul. So basically, it is a control of the organized man-machine system. Okay, ठीक है, चलो. So it is consisting, OR is consisting of the interdisciplinary teams. Okay, that's our question. Interdisciplinary team. Because, for example, I can quote you the one of the example of the industry, that in industry, the production department, they want that maximum inventory should be there in the industry, so that their production do not hamper. So production do not hamper means if any kind of strike or transportation problem or any kind of issues are there. What's the right level? Okay. Then in that case the production should not hamper. So therefore the production department would like to have the maximum raw material in the inventory so as to the production will be smooth. Similarly, the finance department they want the minimum investment on the inventory, because inventory is like a dead investment. Okay, you are maintaining the inventory, there is a cost of maintaining the inventory also. And if you are pile up with the many of the raw material in the industry, naturally your finance will be locked up, your investment is more in the inventory. So finance department would like to have the minimum inventory as possible. Similarly, the personnel management, department or the HR department, they want the semi-skilled labor should do the job, or the with the minimum investment or the minimum salary or wages which is being paid to the employees, the work should be extracted. So their mottos are different. Okay, but if you consider the organization as a whole, then the motto is same. Okay, what is the motto of the complete team? Complete team motto or the organization motto is to have the production smooth, okay, produce as required, and then have the maximum profit. But the individual interest of the department, because the production department would like to have the skilled labor, skill operator, so that production should be fast, and at the same time there is no rejection of the component. So there is a conflicting objectives are there between the each department. So therefore it is necessary to bring all the people from the personnel department or from the production department or from the finance department onto the common platform, and then have a discussion, apply the scientific tool, okay, like a OR, and take the decision. Because organization as a whole, the objective is same, but the objectives is differ at the departmental level. So operation research, it consists of the interdisciplinary team to solve the problems involving the control of organized man machine systems. The nature of the OR, the characteristics, that is a interdisciplinary team approach is there, system approach is there, then helpful in improving the quality of solution. Then scientific, it is a scientific method. Okay, the goal-oriented optimum solution. Then the use of the model require willing executive and reduces the complexity by the use of computers. So, nature of the operation research, or we can say that characteristics of the operation research, they are the interdisciplinary team approach is there. Okay, and the it is a systems approach is there, and it helps for improving the quality of solutions, and goal oriented at the same time. It reduces the complexity by use of computers, because nowadays the high end computing methods are being available. With the with the use of the high end computers, then we are using it, okay, to solve the various complex problems. Okay, so this is what the nature of the operation research is there. Now, what is the scope of the operation research? Okay, so scope of the operation research, that is finance, budgeting, and the investment. Okay. In this sector also, in marketing management sector, the scope is there. Production management, personal management, then purchasing, procurement, and exploration management. So almost in all the sectors, whether it is the production, marketing, or the personal management, there is a scope of the wide scope of the operation research. And in industry also, this is being used, okay, and it is being extensively used for the decision making. The scope of the operation research is there in the research and development, national planning and budgeting, defense services, agriculture and irrigation, education and training. अरे अतुल, ते तुमचं काम बरोबर करशील ते कुठले मॅडमचं ते दिलं का? ऑफिस कॉपी दिली का? दाखवून आणलं का? बरोबर, भेटलं का त्यांना? ठीक आहे, ते तिरकोडे सरला सांगून देशील मी भेटलो म्हणून. National planning and budgeting, then the defense services, agriculture and irrigation, education and training. So the scope of the operation research can be found in the various sectors. Then role in the managerial decision making, that is better control, okay, better coordination, better decisions, and the better system. So the role of the operation research is there in making up the decisions for the better control, coordination, better decisions, and a better system. So basically, it is for improvement only. The OR is being used. For example, if any research is being carried out, the recent research which is being carried out in our country, that when the corona vaccine will be launched, we all of us were worried about the corona vaccine. Okay, and we thought that the corona vaccine should be launched as soon as possible or as early as possible, because everyone, right from the China to the India, everyone, okay, throughout the world, everybody was a sufferer. So in this case, the program evaluation review technique, the PER technique, it can be used, okay, for having the analysis, conducting the analysis, and then deciding when the corona vaccine can be launched. So the CPM and PERT methods also, it is being used in case of the taking up the decision in case of the project management areas. Then what are the phases of the OR? Okay. That is judgment phase, determination of the that is problem. Okay, we have to identify the problem, then the establishment of the objectives and the values. So let us identify what are our objectives. Okay, then the determination of suitable measures of effectiveness. So what are the measures will be taken, what kind of effectiveness will be there. Then the after the judgment phase, the next phase is the research phase. So the observation and the data collection, formulation of hypotheses and models, then observation and experimentation to test the hypothesis, prediction of various results, generalization, consideration of alternative method, and in the next phase, the action phase, that is implementation of the tested results of the model. Because once you arrive at certain decision, then once you take the decision, then it should be implemented successfully for testing the model. So therefore, the judgment phase, research phase, and action phase, these are the phases of the operation research. Then methodology, which is being used in the operation research, like a problem formulation, then constructing a mathematical model, deriving solutions from the model, testing the model, and establishing controls over the solution, and implementing the solution. So the methodology, it includes the problem right from the problem formulation. For example, I can quote at this moment that in one industry there was a problem regarding the medical problem or issues with the basically the labor which is being employed, okay, for lifting the casting. For example, the belt conveyor was there and the complete machining was done on the belt conveyor. Operations were performed on the belt conveyor, and this belt conveyor, it is at a height of 1 meter. Okay, मतलब ग्राउंड लेवल से वो 1 मीटर हाइट पे बेल्ट कन्वेयर था. Okay, and the vendors or suppliers of the casting, they used to unload the casting onto the ground floor. So what was the job of the labor? The job of the labor to pick up the casting and to put it at a height of 1 meter onto the belt conveyor. So the casting of different types, okay, for example, in that automobile industry, the casting which was used, okay, it was of 18 kg, 20 kg, 22 kg, somewhere lighter also, that is 15 kg. So it depends upon the type of model which is being prepared or which is being assembled onto this belt conveyor. So what was happening? Okay, when the labor was employed over there, he used to take a rest or the medical leave after the 3 months, and another labor was employed. Same thing was happening. Again, the labor was continuously replaced to perform the job, and then it is found that the labor which is being employed over there for lifting the casting from the ground level to the put it at the 1 meter height, there was a problem, and this problem, okay, that they wanted to resolve, that why the laborers are taking the leave, what is the problem. So initially you need to have the problem formulation. So problem formulation means you have to study the environment of the problem, and you have to collect the database out of that. And then the second stage, okay, is nothing but the constructing a mathematical model through this database which is being collected. Okay, for example, what is the relationship between the fatigue, okay, and the conveyor length? What is the relationship between the fatigue and the weight of the casting? So likewise, mathematical model is to be constructed, and then applying suitable scientific technique like either the simplex method, okay, linear programming problem, and then coming at the decision, taking the decision or deriving the solution from the model, and then test it. Okay, so testing the model. So the solution to this particular situation which was carried out, it was given that the belt conveyor height is 1 meter, and castings were varying in weight from the 15 kg to 22 kg. So in such cases, okay, instead of lowering down the belt conveyor height, okay, the suggestion was given that let us construct a platform at a height of zero point 0.8 meter, and the vendors were supposed to download their castings onto that platform which is having a height of 0.8 meter, और उनको जो कास्टिंग लिफ्ट करना था वो 0.8 मीटर से 1 मीटर पे रखना था. So difference was for lifting only 0.2 meter. So this particular platform is created, model solution is derived by applying the simplex method, and then it is tested, and then they implemented and establishing the controls over the solutions, and then implementing the solution. So once the implementation phase has been started and once it is being implemented, then it is found that the labor which is employed over there, there was no fatigue developed. Okay, there was no any kind of backache problem or spinal cord problem with the labor, and happily the people were working to for that particular area to lift the castings from 0.8 meter height and to put it onto the belt conveyor of 1 meter. So this is the methodology of the operation research, to study the problem and to solve the problem. So we have studied that the formulating the problem, then constructing the model, then deriving the solution, analytical methods, heuristic method, simulation method, testing the validity, implementing the solutions, and modifying the model. So operation research approach, okay, that is facts, opinions, and symptoms of the problem, technical, financial, and economic information from all sources, detailed information on factors. So this is the information needs. Then the define the problem. Okay, determine the factors affecting the problem, that is variables, constraint, and assumptions. Develop objective and alternative solutions. Analyze alternatives and deriving solution, optimum solution. Determination of validity, recommend action and control and implementation. And the model development, that is maximize or minimize some function and computer service may be used. So model development, when it is when we develop the model, it may be of maximization or it may be of minimization. For example, if we are dealing with the transportation model, so in transportation model, the cost is associated with the transportation of the material from one place to the another place. And in this case, our job is to minimize the total cost of transportation. So total cost of transportation is to be minimized. Whereas in case of the profit sharing or profit development, it is a maximization type of problem. So the model development, it can be of the maximization or it can be of the minimization, and the operation research technique can be used to solve the maximization or the minimization types of problem. So operation research model, let us see the classification of the operation research models. And then based on structure, the physical models, these models give a physical appearance of real object in reduced or scaled up form. These are further divided into two categories, that is iconic model, okay, physical or pictorial representation of the various aspects of the system. So example, blueprints, globes, or the template. The physical model, okay, the physical model which you have studied also. For example, your college building is there, and for a college building, if any structured model is being prepared and which is being available in the institute, showing all building, showing all paths, showing the roads over there, okay, and showing the other infrastructure of the institute, hostels, and all. These are the examples of the physical model. Then analog model. This model represent a system by a set of properties different from the original system. For example, a network of water pipes to show flow of current in electric network, level indicator in automobile petrol pump. These are all the analog model. For example, the level indicator means fuel mileage indicator जो होता है, वो fuel, how much quantity of fuel is being available in the petrol tank or the diesel tank, that can be shown to you. So this is the analog model. Similarly, with this analog model in the modern automobile, the how much your vehicle can go means instantaneous average of the vehicle, fuel economy of the vehicle can be calculated. जैसे कि in my vehicle, okay, the instantaneous velocity of the instantaneous average or the fuel economy is calculated. For example, okay, 15 kilometers, 15 kilometers it can run. Okay, so in available quantity, if the 15 kilometers is the average of the vehicle, मतलब 1 लीटर में वो 15 किलोमीटर चल सकता है. But similarly, depending upon the quantity of fuel which is available in the vehicle's tank, it predicts that how long your vehicle will run. Okay, let us say 220 kilometer, 420 kilometer, or 60 kilometer, and before we cross the 60 kilometer or 200 kilometer, we have to refill the petrol vehicle tank. So this kind of model which are resembling the other type of system, for example, the water pipes to show the flow of current in the electric network. So this type of model, these are called as the analog model. Then the symbolic model, these models use symbols either in the form of letters or mathematical operators to represent the properties of the system. These are further classified into two types, that is verbal models. So these models used to describe a situation in written or spoken manner, spoken language in the form of letters, words or symbol. For example, differential equation representing a dynamic system is nothing but the example of the verbal model. Then mathematical model, okay, the decision variable of the system under consideration are represented by mathematical equation or inequations. Linear programming model to decide the product mix problem, and we used to solve in the mathematics like age of the father is 50, so age of the son is 30, find out the ages of something else like that. So age of the father is considered as a x1, age of the son is considered as a x2. So these are all the mathematical model and the decision variables of the system under consideration. They can be represented by the mathematical equations or the inequations. Then, based on the purpose and the nature, the models are classified as the descriptive model. So, these models are surveys, questionnaire, results, inherence of observations to describe the situation. For example, the plant layout diagram or black diagram of an algorithm. Okay, so this is the descriptive type of model. When you go to any thermal power plant, okay, you will find that the layout of the plant it is being available on the front side of the thermal power plant or the front area of the thermal power plant. So this plant layout will give you the idea of each and everything, like where the boiler is placed, where the electrostatic precipitator is placed, where ash handling system is there, where CHP, coal handling plant is there. So all these things can be represented with the help of the descriptive model. Then the predictive model, these models are the results of queries that what will follow if this occurs or does not occurs. For example, the preventive maintenance, the troubleshooting charts or the procedures. Atu- chart. So predictive model, these models are the basically the it predictive. So for example, when the cutting tool used in case of the machine tool or CNC machine tool, when it can fail, when it is going to fail, so the maintenance can be carried out in the preventive maintenance manner. So the models, preventive maintenance models are used in the industries. Then the normative model or optimization model. These models are designed to provide optimal solution to the problem subject to a certain limitations or constraints on use of resources. For example, LP panel. So this is nothing but there are certain optimization model or the normative model. Then operation research model classification based on the certainty. In certainty, we have the two types of model, that is a deterministic model and the probabilistic model. Hello, हा गणवीर सर. Hello. हो हो. नमस्कार. हा नमस्कार नमस्कार. हो 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 हां हो हो बरोबर रणवीर सर माझं थोडंसं हो का माझा क्लास चालू आहे तर मी हो का मी तुम्हाला थोड्या एक तासाने कॉल करतो. हां एक तासाने कॉल करतो म्हटलं. हां एक क्लास चालू आहे माझा एक तासाने कॉल करतो. हां हो. So based on the certainty, that is the deterministic model. Okay. So if all the parameters of the decision variable, constants and their functional relationship are known with certainty, then the model is said to be deterministic. For example, the games with the saddle point. And another type of model, that is probabilistics or the stochastic model. Okay, in this model, at least one of the decision variable or parameter is random in nature. So like a queuing model. Okay, that is a queuing model is used, then games without the saddle point. So queuing model, okay, it is applicable in case of the railway reservation. Okay, that queuing model is there. So or otherwise the at the airport also. Okay, um, at the airport also the flights are aeroplane is waiting to land. Okay, so these are all the queuing models are there, which are basically the probabilistic in the nature. Okay, so this is what the probabilistic and the deterministic model is there. Then based on the time reference, the statistics model, the static model, and the dynamic model. So static model means this model represent, okay, represent a system at a specified time, okay, which do not account for changes over a certain period of time. So example, replacement of machines when money value is not changing with time, that is a static model. Okay, this model represent a system that is which is not changing on account with respect to the time. Okay, so replacement of machine when money value is not changing with the time. Okay, so these are the static model. In the dynamic model, time is considered as one of the variable, and impact of changes generated by time is accounted while selecting optimal course of action. For example, replacement model where money value changes with time. Okay. So operation research model is based on the method of solution, that is analytical model. So these have a specific mathematical structure and can be solved by analytical and the mathematical technique. For example, any optimization model such as inventory models, waiting line model, this is the example of the analytical model. Iterative model, in this model, solution is obtained from the conclusion of previous step. For example, simplex method for LPP. The simulation model, a computer assisted mathematical representation of real life problem under certain assumptions. For example, Monte Carlo simulation technique, use of random numbers, the forecasting model. Okay, these are the simulation model. In case of the simulation model, okay, mathematical representation of the real life problem is there, which is under the certain assumption, and the use of computers is there. Okay. So Monte Carlo simulation technique is one of the famous technique which is used in the operation research. Then example of the model formulation, that is, consider making a maximum area rectangle out of a piece of wire of length L inches. What would be the width and height of the rectangle? So we are taking up the example of model formulation, and in this particular case, okay, maximum area of the rectangle out of a piece of wire of length L inches. So what should be the height and width and height of the rectangle? Okay. So let W be the width of the rectangle in inches, and let H be the height of the rectangle in inches. So based on this, width plus height is equal to half the length of the wire. Okay, and width and height cannot be negative. So algebraically, this can be represented as 2 in bracket W plus H is equal to L, where, okay, we have seen that this W width cannot be less than 0. So naturally W is greater than equal to 0, and height is also greater than equal to 0. So what is the objective in this particular function or particular model formulation? मैक्सिमाइजेशन ऑफ द एरिया ऑफ रेक्टेंगल. हमारे पास एक वायर है और उसका हमें एरिया मैक्सिमाइज करना है, तो उसकी लेंथ एंड ब्रेथ कितनी रखनी है. ठीक है. सो मैक्सिमाइजेशन ऑफ द एरिया ऑफ द रेक्टेंगल, लेट z be the area of rectangle, then the model becomes maximize z is equal to wh subject to the 2 in bracket w plus h is equal to l. So where this W and H, width and height, are greater than equal to 0. So operation research models which are used in the practice, that is allocation model, okay, then inventory model, then the replacement model, sequencing model, competitive game theory model, waiting line or the queuing model, network model, and the simulation model. So these are the various types of operation research model which is used in the modern industry, and which is used by the statistical people, which is used by the engineers, almost all kinds of engineers, to come at the certain decision. So we are going to study today only the two model, that is LPP we are going to study. So other operation research technique, that is non-linear programming is there, then the dynamic programming, heuristic programming, integer programming, and then the algorithm programming, quadratic programming, parametric programming, then probabilistic programming, search theory. These are all, okay, the other operations research technique which is being used in the industry. Then significance and advantages of the OR. Okay, so what are the advantages of the OR? It provides a tool for scientific analysis, okay, and it provides a solution for various business problems. So therefore, it is a scientific analysis. It is not like a trial and error method. We are taking the decision, we are solving the problem. It basically, the scientific technique is there. It provides a solution for various business problem, enables the problem deployment of resources, helps in minimizing waiting and servicing cost. Okay. So when the waiting line model is being used, in that case, that waiting line model, okay, where the waiting cost is also there. For example, if any super shop is there, Okay, grocery shop is there. If you have been kept on waiting for much of the time, then in that case, what happens? Okay, you will lose the patience and you will go to the another one, another super shopping. So therefore, okay, therefore what we have to do is that, okay, we have to minimize the cost of waiting. If you increase the level of service, then in that case, the your investment also it increases. So somewhere you have to set a balance between the waiting cost as well as the cost of investment. Okay. So operation research it assists in choosing an optimum strategy, renders great help in optimum resource allocation, facilities facilitates the process of decision making. Okay. Management can know the reaction of the integrated business system, helps a lot in the preparation of future manager. So these are the significance and the advantages of the operation research. It is basically the very useful technique for the engineers. Then the limitations of the OR, sir. Limitations of the OR. LPCच्या साईटवर काही अनाउन्समेंट आल्यानंतर पाहावं डायरेक्टर ऑफिशियल एज्युकेशनच्या समोर. The inherent limitations concerning mathematical expression, these are the limitations of the operation research. High costs are involved in the use of the OR technique. Okay, OR does not take into consideration the intangible factors. Okay, and OR is only tool of analysis and not the complete decision making process. So it provides you the solutions as well as alternative solution. Okay, but you have to take a decision based on the alternatives available. Okay, then other limitation, that is bias is there, inadequate objectives. Okay, inherent resistance, competence, then reliability of the prepared solution. So these are all the limitations of the operation research. Then we will come to the our next topic, that is basically the linear programming. Okay. So what do we mean by the linear programming? The word linear means the relationship which can be represented by a straight line. That is, the relationship is of the form ax plus by is equal to c. That is called as the linear programming. So we know that as the x varies, the y varies. So there is a linear relationship is available. So the word programming is concerned with the optimal allocation of the limited resources. Linear programming is to weigh the optimal allocation of the limited resources and optimize the outcome. हॅलो. स्क्रीन दिसत आहे की नाही आहे? स्क्रीन शेअर होत आहे, दिसत आहे ना? बरं बरं. आणि यूट्यूबवर जे येत आहे त्याची लिंक कुठे आहे? त्याची लिंक आहे का? हां, बरं. पाठव पाठव मला. पाठव मला. ठीक आहे. So the advantages of the linear programming (LP), that is, it helps in attaining optimum use of the productive factors. It improves the quality of decision. It provides the better tools for meeting the changing conditions, and it highlights the bottleneck in the production process. Limitations of the linear programming, which you have seen, that is, for large problem, the computational difficulties are enormous. Okay. It may yield fractional value answers to decision variable. It is applicable to only static situations, and LP deals with the problems with single objective. So these are the limitations. Then let us come to the types of solutions to the LP problem. Okay. So there are two types of methods to deal with the LP problem. One is nothing but the graphical method, and another one is the simplex method. So graphical method can be used when we have the two variables in the system. Okay, either x and y or x1, x2, like that. And when the variables are more than two, then we use the simplex method. So the forms of the linear programming, that is a canonical form, okay, and the standard form. In the canonical form, the objective function is of the maximum type. All decision variables are non-negative. And in case of the this standard form, all variables are non-negative. The right hand side of each constraint is also non-negative, and all constraints are expressed in equation. So objective function may be of maximization type or the minimization type. So important definitions of the linear programming, that is the a set of variables x1, x2 is called as the solutions to the LP problem. It satisfies the constraints. And a set of variable is called a feasible solution to LP problem if it satisfies its constraints as well as non-negativity restrictions. So optimal feasible solution, basic feasible solution that optimizes the objective function, okay, is nothing but the optimal feasible solution. So unbounded solution, if the value of the objective function can be increased or decreased indefinitely, the solution is called as an unbounded solution. Then variables used in the linear programming, that is a slack variable, surplus variable, and the artificial variable. So three types of variables are used in the linear programming. Then non-negative variable subtracted from the left-hand side of the constraint to change the inequalities to equalities, and added when the inequalities are of greater than equal to type. It is also called as the negative slack. So the it is nothing but the slack variable, that is non-negative variable, when added to the left-hand side of the constraint to change the inequalities into equalities, and when the inequalities are of the type less than equal to. For example, x1 plus x2 less than equal to 20. So less than equal to means left hand side is having something less compared with the right hand side. So therefore the variable is added as a s or either the s1. This is called as the slack variable. Then the in some LP problem, okay, the variable is subtracted. Okay. So slack variable cannot provide a solution. These problems are of type the greater than equal to type, or the artificial variables are introduced in this problem to provide a solution. So artificial variables are fictitious and have no physical meaning. Are introduced in this problem to provide a solution. So when artificial variables are fictitious and have no physical meaning, are introduced in this problem to provide a solution. So when the basically the constraints are of greater than equal to type, in that case, okay, the sub, that is for example x plus y plus z is greater than equal to type 50, then what we do, okay, we introduce the artificial variable. Then duality, for every linear programming problem there is a related unique LP problem involving same data, which also describes the original problem. The primal problem is rewritten by transposing the rows and the columns of the algebraic statement of the problem. The variables of the dual program are known as the dual variable or shadow prices of the various resources. The optimal solution of the dual problem gives complete information about the optimal solution of the primal problem and vice versa. So the advantages of the this duality, that is by converting a primal problem into a dual, the computation it becomes easier as the number of rows constraint reduces in comparison with the number of columns variable. It gives the additional information as to how the optimal solution changes as a result of the changes in the coefficient, and this is the basis for sensitivity analysis. Economic interpretation of dual, it helps in the management in making the future decision, and duality is used to solve the LP problem in which initial solution is infeasible. So sensitivity analysis, which is basically the post optimality test, that two situations are there. In formulation, it is assumed that the parameters such as market demand, equipment, capacity, resource consumption, cost, profit, etc., they do not change, but in real time it is not possible. After attaining the optimal solution, one may discover that a wrong value of cost coefficient was used or a particular variable or constraint was omitted, etc. So sensitivity analysis, that is, it changes in the parameter of the problem, maybe discrete or continuous. The study of the effect of discrete changes in parameters on the optimal solution, it is called as the sensitivity analysis. The study of effect of continuous changes in parameters of the optimal solution is called as parametric programming. The objective of the sensitivity analysis is to determine how sensitive is the optimal solution to the changes in the parameter. Then let us see the simplex method. So when the decisions are variables are more than two, we always use the simplex method. In case of the simplex method, that is a slack variable, surplus variable, when variable added to a less than equal to constraint to convert it to the equation equality constraint. Okay, it is called as the slack variable, which represent the unused resources. A slack variable contributes nothing to the objective function value. Surplus variable, that is variable subtracted from a greater than equal to constraint to convert it into a equation. A surplus variable represent an excess above a constraint at the requirement level. So surplus variable contribute nothing to be calculated, and they are not contributing toward the objective function. So when the constraints are of greater than equal to type, and for converting into the equality constraint, okay, we introduce the variable which is called as the surplus variable. When the constraints are of less than equal to type, okay, then we add the variable, okay, which is called as the slack variable. So basic solution, the solution is obtained by setting up n variable among the n plus n variable equal to 0 and solving for remaining m variable provided the determinant of the coefficient of this variable is non-zero. So such type of m variable are called a basic variable, and remaining n zero valued variable, these are called as the non-basic variable. So basic feasible solution, that is if it is a basic feasible solution which also satisfies the non-negativity restriction. So basic feasible solutions are of two types, that is a degenerate basic feasible solution. If one or more basic variables are zero, then it is called as the degenerate. Otherwise, it is a non-degenerate basic feasible solution when all basic variables are non-zero. Optimal basic feasible solution means basic feasible solution which optimizes the objective function. The example, okay, z is equal to maximize z is equal to 13x first plus 11x2. So two variables are there, x1 and x2, and it is subjected to the constraint, that is 4x1 plus 5x2, which is less than equal to 1500, and 5x1 plus 3x2, it is less than equal to 1575, x1 plus 2x2 less than 420. So here x1 x2 is greater than equal to 0. So what is the step 1? That is convert all inequality constraints into the equalities by the use of the slack variable. So let us say S1, S2, S2 and S3 be the slack variable. Then introducing the slack variable into the inequality constraint and rewriting the objective function such that all variables are on the left hand side of the equation. So this model can be written as z is equal to minus 13x1 minus 11x2 is equal to 0. Now this is subjected to the constraint, let us say 4x1 plus 5x2, it was less than equal to 1500. So variable we have added, that is S1. Similarly, in the second inequality constraint, the 5x1 plus 3x2 plus S2 is equal to 1575. So x1 plus 2x2 plus S3 is equal to 420, and x1, x2, S1, S2, S3, these are all greater than 0. Then step number 2 in the simplex method is to find the initial basic feasible solution. One feasible solution that satisfies all the constraints, that is x1 is equal to 0, x2 is equal to 0, s1 is equal to 1500, s2 is equal to 1575, s3 is equal to 420, and z is equal to 0. Now S1, S2, S3 are the basic variable because we have put x1, x2 as a beginning solution, first solution. x1 is 0, x2 is 0. So the values of S1, S2, S3 are coming out and these are the basic variable. Step 3, step up the initial table which is given. You can see that on the left hand side, the A1, B1, C1, D1, that is a rows has been introduced. Then the basic variable, that is z, and in the present first step, what is the basic variable? Basic variable is z, s1, s2, s3. Okay, then the coefficients of this z, x1, x2, s1, s2, s3 from the objective function and from the linearity constraint. Okay, solution and ratio. So step number 4, that is choose a correct most negative number from row, okay, A1, and therefore x1 is an entering variable. So calculate the ratio and choose the minimum ratio. That variable s2 is a departing variable. Then in next step, okay, x1 becomes the basic variable because x1 has replaced this s2. Okay, so x1 has become the basic variable and s2 becomes the non-basic variable. Okay, it has left the matrix now. S2 is not available in the matrix. Instead of S2, the x1 has come into the matrix, and then performing the same step, okay, 2, 3, 4, 2, 3, 4, we will come at the solution, and solution can be found, okay, in the last column where solution is S1 is equal to 45, but we told you that slack variables are not going to contribute into the objective function, okay, because their coefficient is 0, 0 S1 like that, 0 S2, and the x1 value is coming out to be 270, x2 value is coming out to be 75. Then putting it into the this one into the optimal solution equation, okay, we can calculate the value of z as 4335. So likewise, the simplex method can be applied in many of the field, right from agriculture, okay, education and training, defense services. At many places, we can apply the simplex method. Then, then we will start with the next topic. I hope that in this 2 hour span of time, I will be able to cover up this transportation model also. So, outline of my presentation in the transportation model, that is introduction, okay, then the solution procedure for transportation problem, finding a initial basic feasible solution, then finding the optimal solution, special case in transportation problem, and maximization in transportation problem and exercises. So main typical issues in operation research is formulate the problem, build a mathematical problem, decision variable, objective function, constraints. So transportation problem, these are basically the subcases of the linear programming problem. The objective is to minimize the cost of distribution of product form from a number of sources or origin to a number of destination in such a manner to minimize the total transportation cost. For example, one of the manufacturer has three plants P1, P2, P3 producing same product. From this plant, the product is transported to the three warehouses W1, W2, W3. So in this case, what should be the quantity of the commodities, quantity of the atom, which should be shifted from plant 1 to W1, plant 2 to W2, or plant 3 to W3, or from plant 1 to W2, W3, like that. This should be decided so that the cost of the transportation it is minimum. Also, it satisfies the demand. The practical example of this one we can take that Aisha Tractor Limited. Okay, they have the plants in India at 7 places. For example, Aisha Tractor Parvanu in Himachal Pradesh, Aisha Tractor in Indore, Aisha Tractor in Zahirabad, okay, nearer to the Hyderabad. So there are 7 places where they are manufacturing the similar kind of product, that is Aisha Tractor. Now, in this case, their dealers network is there throughout the India. So we need to transfer to the Bangalore, Nagpur, Chennai, Mumbai, Delhi, Calcutta, Dehradun, at various places. And the demand of the product it is also varying. It is not constant. For example, in a month in Nagpur, the Asher tractor is supposed to supply 50 tractors. However, in Bangalore region, the demand is 100 tractors. However, in the Kolkata, the demand is only 20 tractors. So, for satisfying the demand of the dealers in that particular area, to transport the tractor from the one place to the another place to the dealer's network, the cost should be minimum, transportation cost should be minimum, and such type of methods are used. Okay. For example, okay, same thing is represented with the help of the network. You can see that the supply, that is a supply from the plant S1, S2, S3, okay, and the demand at the dealers network, let us say D1, D2, D3. The plant source is there P1, P2, P3, and at the warehouses where it is to be shifted, that is W1, W2, and W3. So from P1, we have to take it to the, we can take it to the W1. P1 से W2 भी जा सकता है, W3 भी जा सकता है. Means from plant P1, the material can be taken up to the W1, W2, W3 anyway. So, what are the steps to solve a transportation problem? Formulate the problem and set up the in the matrix form. You are able to see the matrix form on your screen. Obtain the initial basic feasible solution. Test the solution for optimality and updating the solution if required. So these are the plants, plant P1, P2, P3, and demand is D1, supply is S1. For example, demand 21 component, 25 component, 19 component. Here the supply from the plant 20 component, 28 component, and 17. So total comes out to be 65. If the supply and demand is equal, it is called as the balanced transportation model. And if the supply and demand is not equal, it is called as the unbalanced transportation problem. If the model is unbalanced, then in that case, we have to either add the dummy row or the dummy column and give the allocation over there as a give the either supply, provide the supply to this dummy row or dummy column, okay, to make it a balanced problem. For example, if the supply is 65 and the demand is 60, in that case, we would have added dummy warehouse here to have a requirement of 5 in order to balance the transportation problem. Okay. Or vice versa, we can say that if the demand is 65, if the production is only 60, In that case, we cannot deal with the unbalanced transportation problem. We will create an additional plant which is called as the dummy plant, and then requirement of supply of 5 to match with the balance to make it a balanced transportation problem. The numbers which you are able to see on your screen, that is 7, 6, 9, these are the cost coefficient. What do you mean by the cost coefficient? If you transfer one material from plant 1 to the W1, your cost is 7 rupees. Similarly, if you transport the 10 component from P3 to the W1, then your cost will be 4 into 10. So this is the unit cost of transportation which is reflected into the matrix. Then finding an initial feasible solution. There are number of methods for generating an initial feasible solutions are there for a transportation problem. So we can consider the three of them. There are five methods are there. So the prominent method, that is a northwest corner rule or the least cost method, and the Vogel approximation method or the VAM method. So we will see the NWCM, that is northwest corner method. The simplest of the procedure used to generate an initial feasible solution in NWCM. It is so called because we begin with the northwest of the upper left corner cell of the transportation table, and the steps, that is step number 1, we select the northwest corner cell of the transportation table and allocate as many units as possible equal to the minimum between the available supply and the demand, that is S1 D1. Adjust the supply and demand numbers in the respective rows and columns allocation. Then step number 3 in the northwest corner rule, that is if the supply for the first row is exhausted, then move down to the first cell in the second row and first column and go to the step 2. In the If the demand for the first column is satisfied, then move horizontally to the next cell in the second column and the first row go to the step 2. If for any cell the supply equals the demand, then the allocation can be made in the cell either in the next row or column. Step 5, that is we have to continue the procedure until the total available quantity is fully allocated to the cells as required. So the quantities so allocated are circled to indicate the value of the corresponding variable, and the empty cell indicate the value of the corresponding variable as 0. That is, no unit is being transported to this cell. So let us see the northwest corner rule, which is explained with the help of this matrix, with the help of this example. So you know that these are the plant 1, plant 2, plant 3, warehouses W1, W2, W3, and the supply is written on this side, demand is written on this side. We will start with the northwest corner. So which is the northwest corner? P1, W1 is the northwest corner. So in the northwest corner, what is the supply? 20. Requirement is 21. So we can allocate maximum 20. Okay, so therefore this 20 is crossed and 0 will be available. Here 21 is crossed and still there is a requirement of 1. So maximum allocation is done in the northwest corner. Now move vertically because still there is a demand of 1 component. So here we have come. Now here supply is 28, but the requirement is only 1. So therefore we have given the 1 unit here, and here 27 units are there. So this is basically the warehouse demand is exhausted. So therefore now we will move to the next cell, that is in the horizontal direction, where unit cost of transportation is 7. So in this cell, 27 is the supply, but requirement is 25. So again we will allocate 25, okay, and we will move to the next cell where the 2 has been allocated, and then we move vertically, and in this vertical direction, let us say the 19 basically 17 was demand, okay, and the 65, that is here this it is available. So here the allocation it is being done, that is 70. Okay. So similarly we have done, and finally we can calculate the that is by the least cost method. So second method other than the northwest corner rule is the least cost method. That is allocation according to this method is very useful as it takes into account consideration the lowest cost and therefore reduce the computational, okay, as well as amount of time necessary to arrive at the optimal solution. Then select the cell, okay, with the lowest transportation cost among all the rows or columns of the transportation table. If the minimum cost is not unique, then the select arbitrarily any cell with this minimum cost. Then step number 2, allocate as many as units as possible to the cell determined in step 1 and eliminate that row in which either supply is exhausted or demand is satisfied. So this is repeat the step number 1 to for the reduced table and until entire supply at different plants is exhausted to satisfy the demand at the different warehouses. So P1, W1, you can see that the how the it is being exhausted. So in the list cost method, in first row you can see that the 7, 6 or the throughout the table you can see that the least cost is nothing but T3. Okay, so requirement is here 90. So like that, the first row list cost 6, then the second row list cost is 3, next list cost is 5. So total cost of transportation it comes out to be 20 into 6, 5 into 5 plus 7, 5 into 7, okay, and 19 into 3 and 17. So total cost of transportation is 300. This total cost is less than the total cost obtained by the northwest corner rule. Yeah. So, in case of the northwest corner rule, the considerations were not given to the cost. So, therefore, this kind of northwest corner rule method is not effective. However, in the least cost method, the considerations were given to the cost. Okay, so compared to the northwest corner rule, it is one of the effective method which can lead toward the optimal solution. Then the next method, which is very important method, that is a WAM method, which is also called as the Vogel approximation method. It is preferred over the other two methods because the initial feasible solution obtained is either optimal or very close to the optimal solution. So step number 1, that is compute a penalty for each row and column in the transportation table. अक्षय अतुल ते बिलचं पाठवलं का तिकडे तिरपुडे सरकडून घेऊन हा हा नंबर वगैरे दिला का तूच त्याला करून द्यायचं असतं ना विचारून घे ना तिरपुडे सरकडे आहे ना हा So identify the row or column with the largest penalty. Step number 3, repeat step 1, 2 for the reduced table until entire supply at plants are exhausted to satisfy the demand at different warehouses. So let us see the Vogel's approximation method. Okay, again same example is being taken where the plants are 3, P1, P2, P3 and warehouses are W1, W2, W3. And here in this case, we calculate the penalties of not allocating to the least cost cell. So therefore, enter the difference between the two least costs. So on the column penalties, we can say that in the column number 1, W1 के कॉलम में अगर पेनल्टी आप देखेंगे तो W1 के कॉलम में penalty 5, 1 may dash row penalty is also calculated. Then keep on allocating. We can calculate the total cost of transportation. It is 295. What was the cost of transportation in case of the least cost method? 300. Here it is coming out to be 295. So therefore, the Vogel approximation method or the VAM method, it leads towards the optimal solution, and it reduces the number of steps reaching toward the optimal solution. So if the no method is specified, then we should use the Vogel approximation method to find out the solution. So finding the optimal solution, that once the optimal solution has been found, the next step is to test the initial solution has been found. The next step is to test that solution for optimality. Because solution which we have found, it is a feasible solution, initial basic feasible solution. Then we have to take it toward the optimal solution. So there are two methods which are used for testing the solution. One is stepping stone method, another is modified distribution method. In stepping stone method, only one cell is considered at a time, whereas in case of modified distribution method, all the cells under consideration are considered simultaneously. Therefore, it can reduce the time which is being required. And normally we use the modified distribution method. So necessity condition that makes sure that the number of occupied cell is exactly equal to the m plus n minus 1, where the m is equal to number of rows and n is equal to number of column. Each occupied cell will be at the independent position. So to perform the optimality test by modified distribution method or stepping stone method, these are the two conditions which the solution has to follow. In this method, in the stepping stone method, we calculate the net cost change that can be obtained by introducing any of the unoccupied cell into solution. So check the optimality tests for the necessary condition, evaluate each unoccupied cell by following its closed path, and determine its net cost change. Determine the quality to be shipped to the selected unoccupied cell, and trace the close path for the unoccupied cell and identify the minimum quality by considering the minus sign in the close path. So this is the stepping stone method. Now the another method, that is a modified distribution method. In Modi's method is more efficient procedure for evaluating the unoccupied cell. The Modi transportation table of the initial solution, which can be seen from the various steps, that is determine the initial basic feasible solution by using any method. Determine the value of the dual variable, that is having the UI and VJ. You have to enter the numbers, that is UI and VJ, and by using the Cij is equal to UI plus VJ for occupied cell, associate a UI with each row and Vj with each column, okay, and compute the opportunity cost for unoccupied cell. Means if the unoccupied cells are there, and if we shift the allocation from occupied cell to the unoccupied cell, then is there any possibility of reducing the basically, okay, the opportunity cost of the transportation? That's what we have to verify. Hello, hello, hello. Then check the sign for each opportunity cost. If the opportunity cost of the each unoccupied cell is positive, okay, or zero, then the solution is optimal. Otherwise, select the unoccupied cell with the largest negative opportunity cost and draw a closed loop. Assign alternative positive and negative sign at each corner points of the closed loop. Start from the unoccupied cell with positive sign. Determine the maximum number of units that should be allocated to this unoccupied cell. This should be added to the cells with a positive sign and subtracted from the negative sign. So repeat procedure till an optimal solution is obtained. So these are the special cases in the transportation problem. So multiple optimal solution, unbalanced transportation problem, degeneracy in transportation problem, and the maximization in the transportation problem. Because transportation problem is basically minimization type of problem, but there can be a maximization type. So this is the example for your practice. Okay, that is three plants are there. Shipping cost, supply, and demand for power co company. It is being given. Okay, it is available at your screen and try to solve it. So plant threes are given plant one, plant two, plant three, and the cities are one, two, three, four cities where the material is to be shifted. So decision variable, objective function, and the constraint. So same problem of transportation model without applying the Vogel approximation method or the modified distribution method, Modi's method, we can even solve this problem with the help of the linear programming problem. Okay, because it's a part of the LPP only. Okay, so transportation model is a subcase of the LPP. But while dealing with the LPP, the computational difficulties will be more since the variables are more in case of the transportation problem, and therefore it is easy to solve with the techniques like a WAM method or the modified distribution method. Okay. So हॅलो हॅलो हां 3 वाजेपर्यंत येत आहे बरं बरं ठीक आहे Okay. So, so we have covered today the topic of the operation research. Okay, introduction to the operation research. Then we have covered the simplex method. Okay, we have seen the formulation of the model of the simplex method, and also we have covered the transportation model. Okay, wherein in the transportation model we have covered the first one, that is a northwest corner rule, to find out the initial basic feasible solution. Then we have covered the least cost method, and also we have covered the Vogel approximation method, WAM method, and then the how to find out the optimal solution with the help of the stepping stone method or with the help of the modified distribution method. That also we have studied today. So the remaining part in the LPP is a assignment model. Okay, that I will be taking up in the next lecture. And in the OR, we will be having again the CPM and part, which will be taken by me in the next lecture. So you have to practice the numericals. Okay, you can refer the any of the book. Even our book is there. That is quantitative techniques in the business management, which you can take up for the study and uh, which you can use for the practice, because the numerical practice is important in this case. If you do not practice the numericals, then you are not in a position to solve the numerical. And the conceptually, that is studying the environment and formulating the problem is also one of the important steps. So the once you study the problem, study the environment of the problem, then you have to formulate the mathematical model. So operation research is very exhaustive, and it is a different type of scientific techniques are being used in case of the operation research. So you try to focus on the numerical as well as try to clear your concepts again. Okay, I have covered only the two topics today. In the next lecture, we will be again dealing with the remaining topic. And I hope that your examination is also getting focus on the your studies and try to get the good score. Okay. So thank you very much. Wish you all the best. And if Pranay is there, if the Pranay can see me, the coordinator of this particular prerana scheme. Okay. Okay. Pranay?
Sir, shall I end the broadcast?
Yes, Pranay, I have covered the two topics today. Okay,
Okay, sir.
so I shall end the lecture here, and then we will take up the another topics of the operation research in the next lecture, like assignment
Okay,
model,
sir.
CPM
Thank
part.
you. Thank you,
These
sir.
are the remaining
Okay, thank you.
topics.
Thank you so much, sir. No problem.
So thank you very much, Pranay.
Thank you,
Thanks a
sir.
lot.